Okay, so today we want to talk about solving exponential equations and logarithmic equations. So let's just start with exponentials. The processes are very similar. Okay, so with an exponential equation, the first thing we do is just isolate the exponential. Right? So if you have a base to a power, if you have something multiplied by it, if you have something added to it, you remove those, just like you're solving for a variable back in a two-step equation. Once you do that, you're going to take the logarithm of each side. That's where we have some individual options as far as what base log you want to take. I tend to always just take a common log or a natural log, just because traditionally that's the only buttons the calculator would have. Some students now, if they have other bases, they like to use other bases. It might saves you a little bit of time if you have that option. Solve for the variable, we should just get some algebraic equation once we've taken the log of each side. Solve it, it could be a quad, it could be lots of different things that you should be able to solve. Then just make sure to check your solutions. Exponentials should work right if you solve them correctly, but their inverse logarithms a lot of times will have extraneous solutions. Just the more you can make that a habit, the more you'll check and you'll find stuff, and you'll be glad you did it. So let's go ahead and start with a simple example here from our note sheet. This is 3 to the x plus 2 power equals 7. We'll go ahead and take a look at this. Now, as we look at this, some of these we would try to solve just by kind of reasoning it out and things. But I'm really right away, we know that 3 squared is 9. I have no idea what power of 3 you take to get 7. So we're going to have to use our calculators. We're going to have to round this to 2 decimal places. So in order to do this one, our first step is to isolate the exponential, which is already isolated, luckily. So to do that, now we're going to take the log of each side. I'm probably just going to I'll show you, we'll do this one maybe by just taking a common log of both sides, and we'll see how that looks. And then maybe the next example, we'll use a different base. Okay, I tend to use natural logs, but common logs usually people feel more comfortable with. So if we take the log of each side, what you're going to do is take each side of the equation, it becomes the argument of a logarithm. Even if there was a bunch of stuff like added together over here, it would just be the log of all that bunch of stuff, right? They don't each get their own log or anything. The whole side becomes the argument of a logarithm. Now at this point, these steps that they gave us, I kind of missed the point. Take the log of each side, and then I left this out, and then we're going to, I guess it was another step, but we're going to bring down the exponent. That's the, I kind of should have written that up there, but that's the big catch here. If you remember from last week, in just this warm-up today, that if you have the log base A of capital A to the C power, you can bring down the power, right? Bring it out front. So that's what we're going to do here. So this is the property kind of makes this whole thing work. So here, this is just the common log of 7. That's just a number. Don't type it in your calculator yet. You want to wait to type things in as long as possible so you don't get rounding errors. But this exponent we can bring out front as a multiple. So we get x plus 2 times the log of 3 equals the log of 7. Right, so again, I took the common log of both sides, used our property to pull the exponent out in front, and then from here, we are going to go ahead and what we want to solve for x plus 2. Really what you could distribute there, but I would not recommend doing it. I would just at this point take both sides and divide by the common log of 3. Divide both sides by the same thing. So we get x plus 2 equals the common log of 7 over the common log of 3. Now that's something we're going to have to evaluate using our calculator. There's no simplifying we can do there. It is a change of base formula looking thing, but it's not one of our expander condenses at all. And then we'll subtract 2 from each side. So common log of 7 divided by the common log of 3 minus 2 is equal to x. So to find our solution here, I believe our worksheet asks for 5 decimal places. If you say equal, it's fine. I'm not going to count off for it, but just I like to note that I am rounding, so I say x is approximately, because that's what we're doing. So as we type this in, I have the common log of 7 divided by the common log of 2, and then minus 2, and that's 0.80735. Appears to be our answer. Now I'm going to check that. I'm going to say x to the 0.80735 plus 2 power, and make sure that I get the right value. And, oh, I made a mistake early on here. I typed the wrong number in. This is a wrong number here. Sorry about that. Did you all see that as you typed it in? Good. Is it negative 0.22? Okay. Negative 0.22876. I guess it's good to be checked, right? I would have missed it. So let's see. Negative 0.22876 plus 2. So 3 raised to that power. Be sure to put that whole power in a parenthesis. And I get 6.99997. And it was 7. So that checks. That's good. So that would be our solution there. Okay, for our next example here, we have a little bit more going on here, but I want to show you a different technique, because this is still going to be a base 3. Right? We still have a base 3 exponential, just like our first example. This is a different way to do it. They both work all the time. You just get to choose whichever one you prefer. But with this one, we have 4 plus 3 to the 5x equals 8. So to do this, first we're going to isolate the exponential, which means we're going to subtract 4 from both sides of the equation. This is nothing new. This is just old time, rearranging things. So we get 3 to the 5x equals 4. Now at this point, on the first example we did, we took the common log of each side, which works. You could do this problem very similar. It would work. Some people though, especially if your calculator changes bases for you, you might decide to take the log base 3 of both sides. Makes it a little bit quicker. So to do that, you could take the log base 3 of 3 to the 5x, and then the log base 3 of 4. The advantage being is now instead of using this rule to bring down the exponent, we know that if you have a log base a of a to the nth power, you just get n, correct? It just cancel each other out. So the log base 3 and the base cancels, so the left-hand side just becomes 5x. And then log base 3 of 4. This is just going to be a number. We're just going to divide that number by 5. Now, okay, so if you have, you could type log base 3 of 4 divided by 5 in your calculator. Or if you're actually asked for an exact answer, this would be the exact answer. So to do that, we would get, so I would do, now I don't have the change of base formula, so I'll show you, we'll review what we can do instead of that. We got 0.2524. Does that seem right? A little gun shy after last time, right? So we get that. We could go ahead and check it. 4 plus 3, and then 5 to the 0.524 power. And it gives me almost 8, right? So that checks. That's our answer. Now, I don't have the button where I can't type in a log base 3 in my calculator. Okay, so what I had to type in here is I just used the change of base formula, if you remember change of base. from last week, it was that if you have the log base b of x, that can be the log base a of x over the log base a of b. It just allows you to change the base. So I just went ahead and used common logs, and I typed in, to do the numerator, I did the common log of 4 divided by the common log of 3, right? So the 4 went there. This was 3. It went there, right? I'm just doing division. And then it's divided by 5, or you can multiply it by 1/5, however you want to do it. But actually, the calculator does order of operations, so it'll do the log on top divided by the log on bottom. It gets that answer. Then we want to divide that answer by 5. That's how we would type that in. Or you could do, log of 4 divided by log of 3 times 1/5. However, you have to do your order of operations. But if you are going to type it in over a couple lines, make sure you're using your answer key and you're pulling down a previous solution. Because if you don't, if you start to round, it'll just be wrong. Like as soon as you start rounding, it'll be wrong. For our new Delta math, it's probably going to be really annoying because they're going to ding you for some rounding errors. So you really have to make sure you can hang on to your values. If you, for some reason, have to round back here, this step, and you're going to round your final answer to 4 decimal places, you probably want to leave this like at least 6 decimal places when you round it to carry it through. Sometimes that'll fix it, but it's better to let the calculator do the work by typing in things like this. Okay, so a couple more examples here. We have example 3, which is 8 times e to the 2x equals 20. So right away now, we talked a little bit about 2 forms. On our first example, we had a base of 3, but we took the common log of both sides because maybe that's the technology you're using. In the second example we had a base 3, but we took log base 3 because it kind of gives you that calculator shortcut. Okay. Now this one's a base e, so you're definitely, without a doubt, we should be using natural log because we have a button that says natural log, and it's just going to allow us to use this property to simplify instead of having to use the property that leaves us with a bunch of logs. Right, so here, first step is to divide by 8. So 20 divided by 8, 5 halves. Is that 5 halves? So e to the 2x equals 5 halves. Now at this point, I have isolated the exponential, but we want to take some sort of log of both sides. But since the base is e, we're going to take the natural log of both sides. Right, so the natural log of e to the 2x equals the natural log of 5 halves. Well, the natural log and the e cancel, correct? They go away. So we get 2x equals the natural log of 5 halves. Here, something you might consider is most people here would just divide by 2, which is fine. If you already have some fractiony looking stuff, I know that's not actually a fraction, it's just a natural log, but sometimes it's nice to multiply by the reciprocal instead of dividing. It tends to make the work a little nicer. So I might multiply both sides by a half and get x equals 1/2 times the natural log of 5 halves. We can go ahead and type that in. Make sure you fill that in, or put the parenthesis there. So I have x is about 0.4581, going to 4 decimal places again. We should go ahead and check that because tend to make mistakes sometimes. 0.4581. Yeah, it gives you almost 20, so that shows us when we check with the calculator. There we go. Does that work for us? Okay. Example 4 here, a little different. We have 2 bases, right? There's 2 exponentials here. It's not terrible if it's an exponential equals an exponential, even though their bases are different. We can still manage this one. Okay, so with this one, what we want to do here is probably use a common log or a natural log. Because if you pick a log base 4, it's just going to kind of make a mess on the other one side. Again, you might try it both ways and kind of compare. But there's a lot of ways to move this around. So here with this one, we are going to go ahead. Let's use a common log, or natural log. I'm going to go ahead and take the natural log of both sides of the equation. because I know that I need to get the exponents out of here. Right? We're trying to solve for x. It's stuck in an exponent. The best thing we can do is get it out of that exponent. Make it nice for us. So put that around. We'll get x times the natural log of 5. And then we get x plus 1 times the natural log of 4. All right, kind of a little bit strange here, correct? And we haven't seen a lot like this yet. We might have to move some more space here. But what I want to do here is when you have a couple, at least two different x's, right, and they have different things multiplied by them, what we tend to want to do is get all the x's on one side of the equation and get every term without x's on the other side of the equation. Meaning, we're going to need to distribute here. So we'll get x natural log of 5, then x natural log of 4, plus 1 times natural log of 4 is just natural log of 4. Does that work for everybody here? I just distributed that into there. Now, these both have x's. So let's subtract x natural log 4 from both sides. So we'll get x natural log 5 minus x natural log 4 equals natural log 4. But I give us some more space here. Get rid of this one. So then from here, again, we have x natural log 5 minus x natural log 4 equals natural log 4. At this point, once we have all the terms with x's on one side and then the terms without x's on the other, we just want to factor an x out of this pair. If they both have a common factor of x, let's go ahead and pull that out. So we have x times the natural log of 5 minus the natural log of 4 equals the natural log of 4. Now with this, we cannot you could, I guess, you could condense it, but don't. Just leave them the way they are. We're just going to have to type a big string of things in our calculator. This is just some number, correct? Like if it were 10x, I'd just divide by 10. If it's x times this thing, I'm just going to divide by this thing. So we're going to get x natural log of 4 natural log of 5 minus natural log of 4. So actually, this is what we're going to type into our calculator. There's nothing cancels here, anything like that. Just go ahead and input our solution. So natural log of 4, and then in a parenthesis, natural log of 5 minus natural log of 4. And this gives us 6.2126. Okay. So then from here, we're just going to go back and check that in here. Now, a nice way to check that you may, or I don't know if you remember this or not, is that, do you remember that we talked about the store command on our calculator? So what I could do is once I have this, I could just hit, once it shows me this number, I could just hit the store button. And I just like to call it x. So I'm going to store that as x. So now when I go to type these two sides in, it'll grab that. When I put x in here, it'll grab that number. Actually, all the decimal places of that number. It'll work even better. So if we say 5 to the x power, it gives me like 21,998, some giant number. But let's see what this is. This is 4 to the x plus 1 power, and it gives me the same exact giant number, right? So that you can check it that way. Again, I just stored this number as x. I did answer, and then store it as x, and we see that this actually is our solution. So there's quite a bit going on with that fourth example there, right? So there's a lot going on.